and Asha, do the following. Now, you have defined a function that has two parameters. Now, the first parameter is this 2.0, and then the second parameter is this -10, okay? So try to change these two numbers, then let me know the effect on the line, okay? And then can you try to guess what each of these parameters does to the curve, okay, or the line? Here is a straight line. So if you change these two values, how would the shape of this line change? I want you to tell me how it changed by doing experiment, okay? So first of all, you try to change the value of these two numbers and see what happened to the line. And then you let me know what the first parameter does and then what the second parameter does, okay?
Sir, does like at the beginning, like 8.0, does it like changes the y values?
Yes, it changes the y value. In what way?
In the number like which is given.
That's right. If you have a negative number, actually the line tilts the other way, right?
Yes.
And if you have a bigger positive number, the y value goes up faster.
Yes.
Okay, so actually the first number determines the slope of the line, okay?
Yeah.
Okay, so this actually, the first parameter, we actually call the slope parameters because it determines how much a line tilt and in what direction. So now, can someone tell me what the second number does?
But sir, if like it can lower or upper that line.
That's right, it moves the line up and down. And the intersection between the vertical line or the y-axis and the line changes up and down depending on the first parameters. The more negative the second parameter is, the higher up the line is. The more negative the second number is, the lower the line is. So this is why the second number is called the intercept or the offset parameters. So let me repeat that. The first parameter is called the slope of the line, and then the second number is called the intercept or the offset of the line. Okay. Do you know like the point is in a zero dimension, right? A line is a one-dimensional object. In order to determine a line, how many points do you need? Do you know? Two. Yeah, that's right. Because given the same 2 points, you always draw the same line. Okay. Given the same 2 points, you always draw the same line. And so in a sense, two parameters determine a line. Okay. Given the 2 points or two parameters, you specify a line. So here is the thing. Here you're given two parameters, the slope and the intercept or the offset. So these two parameters completely determine the line. Okay. Um, so what I'm trying to say is like for a one-dimensional object, you need two parameters to determine it. Either it's 2 points or you have the slope and the offset variable. You got that? So given the slope and offset variable, a line is completely specified. So let me be more specific. Okay. Let me now share you with my screen. Okay. I'll do that. So we can make this more concrete in coding. Okay. Okay. Are you seeing my screen right now? Are you seeing my screen? So you're able to see it with me first file?
Yes.
Okay. So I'm going to define a function, okay, called align. So I'm going to define a function. This is called line function, okay? And it takes two parameters. The first parameter is the slope, okay? And then the second parameter is called offset or the intercept. And then it returns the double, okay? So this completely determines the line. So the slope will multiply the x. So this is a scaling parameters. So the bigger it is, the bigger the y value is. So the slope is also a scaling parameters. It also determines how fast the line change, okay? And then I add an offset to it. This is where the y-axis and the line intersect, okay? do this. Okay. Well, the stop, let's say, is 3.0. And then the offset equal to +1 here, okay, +1. So, and this line function, okay, is my line 1. So, line 1, 0, always start with 0 because that's the origin. You see that like this function will always multiply x by 2 parameters, the slope and offset. So this function itself completely determines a line. Okay, so a line is a 2-dimensional object that is a 1-dimensional object that completely determined by 2 parameters. Okay, that's what that means. So how are we going to use this in real life? So here's an example. This is Galileo. He's actually the first scientist who studied motions of objects. Okay, and he invented this concept of like space, distance, velocity, and acceleration. Before Galileo, everybody just follow Aristotle. Nobody think of motions in terms of mathematics. So I think Galileo is the first guy who actually like measure the motion of an object using precise mathematics. And he's actually the one who invented this concept called acceleration. Yeah, it means speed with direction. But let's say we just speed without direction. So let's consider just speed for now. So Nayati, do you know what an acceleration means?
It means speed.
It means speeding up. Okay.
Well, change in velocity, like.
That's right. It means change in velocity. Very good. This particular example. So I have a football. I have a soccer, like on a slope. So this is the slope. Okay. The angle. This angle we call theta. So if theta equal to 0, it means there's no slope. It's just a flat line like a table. So the bigger theta is, the more slope this thing is. So the more slope this platform has. Okay. So now I have a soccer. Like originally, like I said, at time 0, it start in this position. Okay. And then we need to give a notation to this position, and we call it x0. Okay. X0 it just means it means any number. So let's say x0 is equal to 0. So let's say it's at home. So let's say at time 0, this football is at home. So x0 equal to 0. Okay. And we all can also say it has the initial speed, or like the initial velocity, or initial speed, and we can we call it like v0. Okay. So v0 can be say can be very big or can be very small, like 0. So we can say so let's say in the very simple case at time 0, so at the very first moment time 0, the football is at x0 equal to 0 and with a 0 speed. Okay, so that means that the ball is just sitting there, not moving. Okay, at time 0. Now because of gravity, I think we all agree that this ball will increase in speed and slide down, right? Everybody agree with that?
Yes.
Okay, and when it slide down, it will increase its speed. Okay, so after some time, t, the ball will move from the position x0 to x1. Okay, we don't know what x1 is. And also the ball will increase in speed from speed 0 to some speed v1. Okay. Are we all okay with this picture? Does everybody understand what this picture means?
Yes.
Okay, because this picture links all the most fundamental concepts in this universe together. It links the space, x, time, t, and the velocity, v. Okay, so it links space, time, and speed, all in this picture. So this picture has all the fundamental concepts to describe any object in this universe. Speed is the change of space per unit time. Okay, you got that?
Yes.
Speed is the change of speed per unit time. Okay, so why is this important? Okay, this is very important. So let me do this. Okay, let me do this. Let me be more concrete. Okay, so v0 equal to, let's say, 0. Okay. Oh, sorry. So here's the math programming part. Okay, let's see. So let's say v0 equal to 0. Okay. Everybody seeing me doing this coding?
Yes.
Okay. So v0 equal to 0. Okay. But after some time t, say let's say t equal to 10 seconds. Okay. 10 seconds. Okay. The speed v1, okay, equal to 10. So can somebody tell me what the speed is? What should the speed is? How do I compute the speed of this object? So this object goes from speed 0, like not moving, to a speed equals, say, 10 meters per second in 10 seconds. Okay, it takes 10 seconds to complete this process. Oh, I'm sorry. Sorry. Oh, sorry. So I want to say x0. That's the position. Okay. So this object start at x0. Okay, which is the initial position. We call it 0, and after 10 seconds, the next position is at 10 meters. So this object moved 10 meters in 10 seconds. So what's the change of distance here? Anybody know? How do you compute the change of distance here? What is it?
10.
Well, how do you get 10? Yeah, okay, it's 10, but how do you get it?
So like this x1 minus x0, like.
Very good. It's x1 minus x0. That's very good. So this is the change in distance. But the speed is not just the change in distance. Speed is the change in distance per unit time. Okay, so this x1 minus x10 happens in 10 seconds. So what we really want to do is like, what happened per seconds? So we have to divide it by time. Okay? Everybody understand this one?
Yes.
When we say per unit time, we always divide the process by t. Okay? S is 1. So what does this 1 mean? It means the object is moving at 1 meter per second. Okay? So the average speed of this process, of this object, is 1 meter per second.